Right. Tonight what we are going to be learning is various techniques that are utilized to separate types of mixtures, either homogeneous or heterogeneous. But it's very important that you understand the differences between physical and chemical properties. These are very similar to physical and chemical changes. It's just kind of like a reiteration. We do not expect you to understand the difference between a change and a property, just between physical versus chemical. Physical, as you learned with the notes last night, is that it's a property that you can't that you can observe without actually changing it, what the substance is made out of, such as boiling point of water. If I observed water boiling, okay, its boiling point is 100 degrees Celsius, but it is H2O as a liquid or H2O as a gas. It has not changed the composition of the actual element or compound. A chemical property, on the other hand, in order to observe it, you are actually going to have to change what it is made out of. So if I were to burn something, okay, to see if it was flammable, I would be burning it, which would be causing a chemical reaction to go on, and it would actually be changing what it was made out of. Some various types or properties that you should just kind of be familiar with are color. So if I just said that it was blue, that would be a physical property. Any physical characteristics would be physical properties. Odor, so what it smelled like. Density, boiling point. If you look at boiling and melting, any phase change will also be a physical property or physical change. Solubility means how well can it dissolve. So if it's able to dissolve well in, let's say, water, then it would have a high solubility. If it doesn't, it would have a low. But either way, you are not actually changing what the substance is made out of. Chemical properties is primarily what we're concerned about in chemistry, but some terms that you will need to know is like reactivity. So if it's literally reacting with something, if it's reacting, it's going to be changing what its property or compositions are. So therefore it would be a chemical one. Flammability and rusting or oxidation. We would mostly look for the rusting word. So if you see any of these, they're the same signs that you would say for a chemical change. These are also chemical properties. So now let's talk about how to separate various mixtures. One type of separation that people should be pretty familiar with is filtration. And what filtration does is it separates on particle size. What you kind of want to think of is a coffee filter. So you have your coffee grounds, you have the filter itself, which is the white substance that you put in your coffee filter, and you pour your coffee grounds with your hot water through the filter. The small particles that went through the filter, or the water that now has some coffee attached to it, is known as the filtrate. The larger particles that stay in the filter are now the residue. Some types of mixtures that you can separate are solids and solids. They do that with different size grains or granules of rocks, for example. So if you have bigger rocks and you want the smaller rocks to be able to go through, you can kind of sift it through it. It works very similar to a sifter. And solids and liquids, that would be similar to coffee. Once again, you can think coffee filter is filtration. Another one that is a classic example is when you have noodles and you use a colander. When you pour noodles in water, you're separating the water from the noodles. The noodles are considered the larger particles, so that would be called the residue, and the water would be known as the filtrate. Another one that they give an example of is sand and water. So if you look at this is more of a one that you would see in lab, but you have your funnel right here, and you have a piece of paper, and we will be doing a lab with this, and you pour your mixture from here through your coffee type filter, and the liquid in our lab will go through, or the thinner, smaller particles will go through, and the larger particles will stay up and will not be able to penetrate through that filter. Another type of technique that you can use is evaporation. And evaporation uses the process of phase change. Okay. The mixture is heated, so evaporation, just think of something being evaporated. So let's say we had some salt water, okay? And we have this wonderful salt water, and we use the power of the sun, and we heat the water and the salt, and what's going to happen is the water is going to evaporate, and the salt is going to be remaining behind. So a lot of times it's a mixture, the mixture type would be a dissolved solid, such as salt, and the liquid would be water in this case. So an example would be for a lab setting is you use this lovely evaporating dish, it's just basically just a ceramic bowl, and you pour your liquid in it that has the dissolved particles in. You heat it up either through a Bunsen burner or a hot plate or whatever source of energy you have. You could use the sun. And what's going to happen is that the water, which has a lower boiling point, is going to evaporate off. Okay, and then the salt will remain behind. The only problem with evaporation is that you are not able to collect that vapor that is going to be pulled off. It is basically just in order to separate the two. If you do not care about collecting the water, but you do care about collecting the salt. Distillation is a process that uses boiling point, and this is a really cool process. I think basically it's easiest for me to show you how it works. So what you have is you have this very, very expensive contraption over here. I remember using them, and I broke one of these tubes right there, and it cost me $200 to replace in college, which is a lot of money in college when you have none. So basically what you do is you have this wonderful solution, a homogeneous mixture. It could have 2 liquids, it could have 3 liquids, whatever it has in it, you need the liquids to have separate boiling points. And what you're going to do is you're going to heat this puppy up. Okay, and what's going to happen is the things with, it talks about lower vapor pressure and stuff like that, but basically what's going to happen is the particles, let's say we have some particles, I'm going to say the red particles have a boiling point of 70 degrees, whereas the purple particles have a boiling point of 100 degrees. What's going to happen is when I heat this solution up, the particles that can boil at 70 degrees will start going up into a gaseous state, and they're going to leave the solution. When they do that, they're now a gas at this point. And gases, as you've learned, want to take up as much space as possible, so they are going to go down this tube. Okay, the particles that were at 100 degrees now are still remaining in the solution because it hasn't reached 100 degrees. It can't boil or turn into a gaseous state. It's only the particles that are at 70 degrees that can do that. So now the gas is spreading, and what you do is you put it through a condenser. And this condenser has cool water running on the outside. So as soon as you hit that gas with cool water, it's going to instantly turn to a liquid. And that liquid is going to go down the condensing tube through a funnel, and then you can catch the liquid that has a boiling point of 70 in another beaker. And so now, after everything's said and done, I now have collected my 70-degree solution over here, and I have had my one that boils at 100 degrees in this. So now I have separated the two liquids. Okay, this is going to be a very important test question on that you will see, so it's important to understand. So what it asks is, how would the heating curve, so remember back to a previous unit where we went like this, okay, of a substance with a boiling point of 50 degrees look different from a substance with a boiling point of 25. So you would use distillation typically to try to separate these because they have a difference based on a different physical property of boiling point. So it'd be easy to separate using the distillation. So originally what you would have is this wonderful solution, and both of them would be heating up. So I'm going to use one as purple, one as red. I'm going to say the one that's red boils at 50 degrees. The one that's purple is at 25. Originally, all they are doing is being heated up together. As soon as it turns 25 degrees, though, what's going to happen is the purple is going to start to boil, just like it showed in the distillation. So we're focused right here, basically, for this guy. So here, everything is a liquid. And then here, everything is going from a liquid to a gaseous state, so it is boiling. Meanwhile, while that is boiling, this one that boils at 50 is still just heating up. It's only when you would reach the, when the solution would make it to 50 degrees that it would start to boil too and go from that liquid to a gas. So this we would know would be at 50 degrees. Crystallization is the process of separation used by dissolving. Basically what you do is you have It's the exact same process that's used for rock candy. So, for example, with sugar, you put sugar in a water, it will dissolve. You pour a ton and ton of sugar in there. You keep heating it up. What happens is that it will remain dissolved as long as it's hot enough. As soon as you allow it to cool, those crystals will form. And that's exactly how rock candy is. The Hoffman apparatus is the most unique apparatus that we have. What it can actually do is separate compounds. Okay, and this is the only one that can separate a compound. Everything else that we have talked about can separate a compound from another compound, or an element from a compound, or something more complicated. But this one actually is able to break the compound up. Okay, and what it does is that you need to use electricity, lots of energy. Okay, and what we're going to do is we're going to pass that energy through water, or the electricity through water, and what it will do is it will separate water, which is made out of H2O, so hydrogen and oxygen, and it will literally split hydrogen and oxygen in the water. So you'll be making hydrogen and oxygen. These should be diatomic, which you don't need to worry about right now. But what happens is that it literally will break the bond between that hydrogen and that oxygen and allow the hydrogen to be separated from that oxygen. This is the only one that breaks up a compound. Okay, and this is what the apparatus looks like. So you basically have water in this tube, and you have a power supply, so electricity in these. And by shooting the electricity through, you are going to produce hydrogen and oxygen. A very similar process is used on a nuclear submarine, and what they do for the nuclear submarine is they take the water from the ocean. Okay, and they use nuclear power. That's the whole point of the nuclear sub, is to use nuclear power. And they use that nuclear power, and what they do is they break the water that's found in the ocean, and they break it up to produce your hydrogen and your oxygen. And they don't care about that hydrogen, so they basically shove it outside of the sub, but they use that oxygen so that you can breathe under the water. Otherwise, they would run out of oxygen as far as the supply goes, and they would need to resurface a lot more often than they do using this type of a method. So hopefully you can study these, become very familiar with the various separation techniques of mixtures. Some I'm hoping you're already familiar with. Others I know you're going to need to study. And have a great evening.